Okay, we're over here at GoToMath.com. Let's go up here to the Algebra, click on that, and go down to Absolute Value Inequalities. That's what we're going to be working on. Okay, so let's take a look at this one here. We got the absolute value. Well, actually, we're not doing that one yet. I just woke up. Okay, so let's click on this one here. So we have the absolute value of 17x is greater than 0. And we want to find the solution set and write an interval notation. Okay? So let's go over to the magic board. Just think 20 years ago would have been magic. Or actually not even that long ago. So we've got the absolute value of 17x. The absolute value of 17x is greater than 0. Okay? Alright, so the way this is going to work here is a lot like the previous section where we had absolute value equations. We pretty much do the exact same thing, except we got a twist going on here with this guy here. Okay? So this is the story. So what we're going to do here is we're just going to drop the absolute value bars, write 17x is greater than 0, and then solve for x in this problem. Now, what we're going to also do is we're going to do this again, drop the absolute value bars, we'll write it again over here, 17x, but this time we flip this guy, multiply whatever this is by -1, but -1 times 0 is just 0. Okay? Got it? Alright. Now let's go ahead and just solve for this one here. So if we multiplied 1 over 17 to both sides, we'd end up with x is greater than, here I'll just go ahead and do that. Or think of bringing the 17 diagonally down. So this still becomes x is greater than 0, right? 0 over 17 is just 0. So x is greater than 0, and then in this particular case we'd end up with, I guess we better not skip any steps here. I didn't mean to write that. So this is 0 over 17, which is x is less than 0. Okay? X is greater than 0, x is less than 0, and you're probably like, what the heck? Well, if we looked at a number line, alright, and put arrows on both sides, going off to positive infinity, negative infinity, and we put 0 right here. So what we'd have to do is put an open circle, because this doesn't include 0, we don't include it, and it's everything going off in this direction and everything going off in that direction. In other words, you can pick any number on the number line, plug it in, and this will be true. Except you can't use 0, right? We can't plug 0 in, because if you did 0, let's look at this for example. If we plugged 0 in into this, we'd end up with the absolute value of 17 times 0 is greater than 0, and that's false, because 17 times 0 is 0, and the absolute value of 0, which is just 0, is not greater than 0, is not greater than 0. So you see, so we got to throw this, throw that out, throw 0 out. Okay? So there you go. However, we want to write this in interval notation, and that is, there's a couple ways of doing this, okay? But I think the way I actually do this is, okay, we're going to write this interval here to the left of 0, so that would be going from 0 to negative infinity. Now we use a parentheses right here because we don't include 0. Union 0 to infinity, going off in that direction there. Okay. Alright. Like I said, you could do this, you could say r and then throw out 0. The real number minus, throw out 0. I don't know, there's a number of ways of doing this. But this is going to be the way we do things right here. Okay. Alright, so let's go back to the web page. Hit the answer there. Right, so as you can see here, and then of course we can type this in up here, and I added a new feature because I was bored, and like I said, you want to use this either in Chrome or Internet Explorer. I wouldn't try this in anything else. Let's see, so you got negative, just push there, bring up the infinity symbol, 0, union, and then 0, comma, to infinity, right? Correct. Okay, so there you go. You can come on by, practice that, and I'll see you later. Okay, so we're over here at gotomath.com working some algebra, and we're looking at absolute value inequalities, and let's do 1.2 this time, a lot like 1.1. Except we got a little something different in here. So we want to find the solution set and write in interval notation. So we got the absolute value of 12x is greater than 17. Right, so let's bring up the whiteboard. Okay. The absolute value of 12x is greater than 17. All right, so we're going to end up with two inequalities here. And so the first one, we drop the absolute value sign, so we have 12x is greater than 17. 12x, now we flip the sign and multiply that by a negative. There you go. Okay, it's just what we do. Alright, so then we go ahead and solve for x in both of these here. Now, this thing is pointing to the right. I don't know if I mentioned this in the last thing. You need to think of the word or. Okay, think of the word or. Okay, and we'll get to that here in just a second. So we go ahead and solve for x in this. That means we're going to multiply both sides by 1 over 12, or you could think of moving the 12 diagonally down, however you want to think about that. I mean, technically we are multiplying both sides by the reciprocal of this to isolate x. Alright, so we know that x is greater than 17 over 12, and in this particular one here, we're going to have x is less than negative 17 over 12. Less than negative 17 over 12. So this means or. That means that x is greater than 17 over 12, or x is less than negative 17 over 12. Okay, and let's just go ahead and let's see. I'm going to do how about we do the number line in a different color this time. We'll do the number line there. And so if this were 17 over 12, which is 1 point something or another, so we have 17 over 12, and then this is going to be, we'll put 0 right here, negative 17 over 12. And so this says everything greater than. Now we put a circle here because we don't include it, okay? And then everything greater than, right? Put a circle here, and everything less than. That's what this says here, okay? So now we'll go ahead and write this interval. So if we're going off in this direction, we're going negative infinity. This is 17 over 12, obviously. We put a parentheses here because we don't include it, okay? Union, the union. Now if you don't know what the union is, you need to go back to the sets. This is an interval. This is an interval right here, but it's a set of numbers. All right, and then we got 17. Yeah, go into the up to the very top in the contents and check out sets. All right. Okay, so there you go. Okay, we got that. All right, let's move over here. Click on the answer. Negative infinity to 17 over 12, union. Okay, and then you can go ahead and type that in right there and check that out. make sure that works. If you got any problems, make sure you go up to contact us and let us know if there's any kind of issues you run into with that, because you never know. Okay, so there it is. Come on by, practice, and I'll see you later. Okay, we're over here. Go to math.com, click on the algebra. Let's go down to absolute value and inequalities, and we're doing 2.1, I believe. All right. Okay, so it says find the solution set and write an interval notation, and that's what we're going to do. So we've got the absolute value of x plus 5 is greater than 0. X plus 5 is greater than 0. I got to write that down. Alright. So the absolute value of x plus 5 is greater than, actually, was that an equal sign in there? Yes, it was. Ooh. Okay, so we're going to go ahead and write this as two inequalities. We say x plus 5 is greater than or equal to 0, and then we say x plus 5, we flip this guy, is less than, and of course multiplying that by -1, but then that just still remains 0. Okay? So we go ahead and solve, and so we end up with x is greater than or equal to -5, right? And x is less than -5. Whoops. I just about messed that up. Okay, so let's go ahead and draw a number line, because that's always seems to be easy to look at when we're writing our interval. So if I have, this says this is kind of silly now that I look at it. Yeah, okay. Anyway, I guess it's one of these trick problems. Here's -5 right here. Alright. And if we looked at this one here, x is less than or equal to -5, so we put a solid dot, and it's everything to the left of -5. And then this one here, right, it's a solid dot, and it's everything to the right of -5. And you're like, well, what the heck, that's everything. Well, you're right, it is. Negative infinity to positive infinity. And here's the reason why. Because this absolute value sign right here, the to the left of this, okay, this is either going to be, whatever we put into here, this is either going to be 0, it can never be a negative number. Okay, this can never be negative over here, because the absolute value signs cancel the negative out and makes it positive. So the smallest number this could possibly be is 0, but this says 0 is greater than or equal to 0, and that's true. Alright, and then of course if this is any negative number, well, I already said that, if this is any negative number inside here, it's going to be positive. And so that positive number, as long as it's not 0, let's say, is going to always be greater than or equal to, or greater than 0, right? So what we end up with is, well, we end up with that, right? We end up with everything on the number line. So that's kind of a silly one, but it's also kind of tricky, because people are like, wait a minute, that's everything. Now, you know, I'm going to add to all this. Let's say, for example, we had something like this. Okay, is that even possible? No. There's nothing you can plug into x right here to get this to be less than 0, because remember, the absolute value bar makes all negative numbers inside positive, and of course you could have 0 in here, so this could never happen, right? No matter what, there is no solution set for that. So be careful about things like this, okay? Alright, negative infinity, positive infinity. Yeah. And of course, you get over here, and there you go. I guess we could go ahead and check this and make sure. I always hate checking these things because if they're wrong, then I got to go in and recode, and I'm not in that frame of mind today. Yeah, well, correct anyway. Okay, so there you are. We're over here at somewhere. We're over here at gotomath.com. Come on by practice, and I'll see you later. Alright, we're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities, and we're doing 2.2. 2.2, find the solution set, write in interval notation. So we've got the absolute value of x plus 9, and of course that's got to be in the way, is greater than or equal to 25. Alright, so let's take a look at that. What are we at here? The absolute value of x plus 9 is something greater than or equal to 25. Greater than or equal to 25. Okay, so once again we drop the absolute value bars. And then we do it again. Except remember this time now we flip the symbol here. Flip the inequality. Make that negative. Okay, so let's go ahead and work on this one. So x is greater than, so we bring this 9 over to the right hand side and becomes negative, and so now we have x is greater than or equal to, and does anybody know what that is? Okay, so x is greater than or equal to 16, and then go ahead and work on this side. 25 minus 9, and what do we got on that? That's going to be 34 equal to negative 34. So this is kind of interesting here. Alright, x is greater than or equal to 16, x is less than or equal to negative 34, and I shouldn't say and, because technically this is an or in here, okay, that x can be greater than 16 or x can be less than or equal to negative 34. And let's go ahead and write draw up a number line. So we'll put 16 over here. Now look, it includes it, so I'm going to put a solid dot and then write everything going off in that direction. Then negative 34, we'll just put it here. How's that? And then 0 is somewhere in here. Okay? And then of course we include it and everything going off in that direction. So this makes it a whole lot easier when we go ahead and draw up our number line. So we got going from negative infinity to negative 34. Now we're going to include it, so that means a bracket. Okay, that means bracket. Alright, and then union bracket, because we include it, 16 to infinity. Okay. So we can't use things in between, and you can always check this. For example, take 0, and if you were to plug 0 in right here, get 0 plus 9 is 9, and the absolute value of 9 is 9. But 9 is not greater than or equal to 25. You see that? But if you did like negative 34 and you plugged it in, you would see that you get negative 25, and the absolute value of negative 25 is 25, and 25 is greater than or equal to 25 because it's the equal part that makes it true. Alright, so there you go. Okay, so let's, what else to be said here? I think that's about it. That's about it. Alright. Okay, union 16 to infinity. Okay, looks good. Alright, so we're over here at gotomath.com. That's where you can come on by, practice this stuff, and I'll see you later. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities, and I believe we're doing 3.1. Right. Find the solution set, write in interval notation. So we got the absolute value of x minus 1 is greater than 39. Why does it seem like we just did something like this? I don't know. Alright, whatever. X minus 1 is greater than 39. So we go ahead and drop the absolute value bars. Right, and we'll do that again over here. So remember, this time we flip the sign, make it negative. Okay. So go ahead and solve for x. So we got 39 plus 1. And then we have x is less than 39, adding 1 to both sides. Okay, x is greater than 40, x is less than 38. Remember, it's an OR statement. Now, the way you can think of this OR statement here, think of this being the letter for right. Okay, the letter for right. And right means, think of this as being an arrow. Think of this as being an arrow, and it's pointing to the right. There you go. Okay, because the other word that we'd be associating with is the word and when we deal with these things. And of course there is no R in and. So this has to be going to the left. Okay, so you just got to remember one of them. So that's a little device there that you can use to remember. And OR means it's going either that way, or the number is either in the set, this set, or it could be in this set here. Okay, so let's go ahead and draw this guy, even though it's not straight. So we got negative 38 over here. Now remember, it doesn't include negative 38, so we put a hole there. There's a hole, missing point. Can't use it. And then of course we have 40. We'll put 40 over here, 0 somewhere in the middle. Put a hole, and everything going to the right of 40. And so we can write this as negative infinity to negative 38. Parentheses, remember now, union 40 to infinity. Okay? Right. Okay. As you can see there, you can type that in, check your work, whatever you want to do. Alright, so there you go. We're over here at gotomath.com having a ball. Well, I'm not sure about that, but anyway, okay, bye. Okay, we're over here at gotomath.com working some algebra. Let's go down to absolute value inequalities, and we're looking at 3.2. 3.2. Find the solution set, write in interval notation. Alright, so we got the absolute value of x minus 9. You should be catching on to these if you've been doing the previous ones. It's greater than or equal to 31. Okay. Should be able to work some of this stuff out. There was a dot there. Okay, so we have the absolute value of x minus 9 is greater than or equal to 31. 31. Okay, so go ahead, drop the absolute value bars, and we'll do that again over here. Make that a negative 31 this time. Not a 39, but a 31. My brain's all mixed up. Okay, so we go ahead. Now remember the word or here. Okay, so we go ahead because it's pointing to the right, remember. Go ahead, solve for x over here. So we have x is less than or equal to, and we bring that 9 over to the right. So that becomes what? 40. right? Okay, and then same thing here. Negative 31 plus 9. X is less than or equal to, and of course that's going to be what? So you're trying to think. Negative 22. Okay, so let's go ahead and draw up a number line so we can best see this. And it's not exactly the straightest line in the world, but it'll have to make do. So we have 40 over here. Let's just put 40 right here. Now look at here, we include 40, so I'm going to put a solid dot, and it's everything x is greater than or equal to 40. Okay? And then this is x is less than or equal to negative 22. Put negative 22 over here, right, and go off in that direction. Okay? And so now we have negative infinity to negative 22. Now we include it, so we're going to put a bracket here. Union, right, and then 40 to infinity. Okay, so this here helps you, once you write this out, this helps you be able to draw this in, because you can just do, okay, that one, and then union, and then this guy right here. Okay, so in other words, you can pick a number either here or over here, right, to make this a true statement. All right, bam, there it is. So let's go over here, make sure the scripting is all correct. Negative union 40. The programming, whatever you want to call it. Where are we at? That's it. That's all we need to talk about. We're done talking about that. Let's move on to something bigger and better. So we're over here at gotomath.com. Come on by, practice, and I'll see you later. We're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And we're looking at 4.1, it looks like. So we've got the absolute value of 12x plus 6 is greater than 29. Okay. And you see that little thing says refresh right there. It comes up. Click. That means you just click that and get a new problem if you want, instead of having to click the button. I'm sure I've said that once or twice. Okay, let's bring up the magic board. It's magic. Can you imagine if you pulled out one of these things back 300 years ago and showed the Indians, or wherever you are on the planet? They would just like, you are from outer space. Was that 61? I can't believe that would be 61, but it's 16. That's what I'm talking about. Actually, it was 6. My God, I'm seeing things. Yeah, the people that you showed this to would just be like, you are from somewhere else. Wouldn't you like to be a time traveler just for one day? Okay, travel back in the past with your laptop computer. I don't guess there'd be any internet, but anyway. We got the absolute value of 12x plus 6 is greater than 29. You know, so I'm like sitting here thinking, what are things going to be like 300 years from now if we're still alive? We hadn't. People are trying to, I don't know, man, bad things going on right now. I doubt if we'll be drawing on laptop computers, but I got a feeling we're still going to be studying math. More than likely, somehow, some way. We've got 12x plus 6 is greater than 29. 12x plus 6 is less than negative 29. Now, of course, remember this is pointing to the right, so need to think of the word or. Okay, R for right, pointing to the right. Okay, Alright, so let's go ahead and solve for x over here. And we end up with 12x is greater than 29 minus 6, right? And then, of course, multiplying both sides by 1 over 12. I should go ahead and simplify that. Right, let's just go ahead and do that now. So x is going to be greater than or equal to, so let's see, we got 29 minus x, or 29 minus 6, and then divide that by 12. I don't guess that's going to reduce down any. And that looks like 23 over 12. over 12. And then let's do the same thing going on over here. I'm sure probably we will be doing math not like this, but in three-dimensional space, I think is what's going to happen. That is, we're going to be more than likely wearing some kind of device, goggles or something on our heads, and looking into a three-dimensional space where holographic image is projected. And that's my guess. I mean, I don't know. That was something I thought of many years ago. And it turns out that it looks like Microsoft has got a device. We're about to revolutionize the way we see the world. The monitor, or whatever, negative 35 over 12. Okay. I'm almost positive that's what's coming next. We will all be wearing the monitor on our face. Yep, that is what's coming, I can promise you. 23 over 12. I don't know how that's going to affect the rest of everything else, but hopefully you'll still be able to watch these videos. I don't know. 385 over 12. But think of all the new technologies that are going to evolve from that. It's going to be crazy. Okay, so we don't include it, so it's everything to the left of it. And everything to the right of 23 over 12. Okay? And I wonder if I can sneak this in right down here before that page break. So we put a parentheses here because we're not including union, and then 23 over 12 to infinity. Okay? And right, you can always check these things, kinda pick some numbers that aren't in this interval and plug it in up in the original, and it should be false. Something's fishy. Okay, so there you go. Let's try to remember all that. Can we remember? If I can remember it. We remember all that. Negative infinity, negative 35 over 12, union 23 over 12 to infinity. I'm still thinking about those different kind of internet we're going to be dealing with shortly, or computing or whatever. It's kind of throwing my mind off. Threw my damn brain into a spiral. Alright, there we are. We're over here. Go to. I'm like, oh my god. Can't handle any more of this. We're over here at GoToMath.com. Check it out. See you later. Alright, we're over here at GoToMath.com. Getting crazy. Click on Algebra. Let's go down to absolute value inequalities. And I think we're working on 4.2. Absolute value of 2x minus 20 greater than or equal to 35. There's absolutely no reason why you shouldn't understand this stuff if you work through all these problems, I promise. you are going to make an A on your test. Did I show you how to make an A on a test? I don't think I did, other than this is one way of doing it. There's actually an easier way of making an A. I'll show you here in just a second. Okay, we wrote that down. Let's get over here. Now, the easiest way to make an A on a test, and of course I think people use red, maybe, I don't know. The best way to make an A on the test is just write A on your test. In fact, you can even write A+. And there you go, you made an A on your test. I actually showed a student that one time and she got kind of mad. Okay. Now this is how you make an A on your test. You go to math.com and practice. 2x minus 20. That's the old-fashioned way. Is greater than or equal to 35. Practice, practice, practice. Okay, so let's go ahead and drop those absolute value bars. Is greater than or equal to 35. And then we'll do that again over here because, well, we have to. Is less than or equal to negative 35. Got it. Got that? Let's make sure we wrote everything down. 2x minus 20 is greater than or equal to 35. Okay. So over here, you should have already have that worked out by now. Greater than or equal to 35 minus, no, plus 20, sorry. Right, so minus 20, take it to the other side, becomes positive. And so now we have, what is that, 55? We'll go ahead and do that over 2. Okay. X is greater than or equal to 55 over 2. Yep, 55. Now remember, it's pointing to the right, so we use the word or. Okay. And or, I don't, did I ever mention that or means really union? You can associate it with a union. Okay, I don't know if I did or not, but anyway. Never know. Negative 35 plus 20. Negative 35 plus 20 is negative 15. So we have x. Take that 2 diagonally down. Right? And of course, I've been drawing number lines, and we might as well not stop doing that. So, attempt to draw a straight one anyway. Okay. So 55 over 2, we'll put that about right here. Just some arbitrary place. We'll say, okay, 0 is there, and then negative 15 over 2 goes there. Okay, and so remember, this includes it. I should have done that. So that's a solid dot. Everything to the right, solid dot. Right, x is less than or equal to. Everything to the left. Okay, so we have negative infinity, negative 15 over 2. Now remember, it's a solid dot, so we use brackets, union, bracket, 55 over 2 to infinity, like that right there. Okay? So you are well on your way of becoming a mathematician. Yeah, I didn't say mathematician, I just said mathematician, whatever that is. Alright, so there you go. Got it? What are we doing? Oh, we need to go back to the page. Forgot what the heck I was doing there. Started thinking about magic. We got negative infinity at a negative 15 over 2, union 55 over 2 to infinity. Okay, looks good. And you can try that out in the green box. Let you do that. Alright, so we're over here at GoToMath.com. Practicing. Come on by. See you later. Okay, so excuse me, we're over here at GoToMath.com. Click on the algebra. Let's go down to absolute value inequalities. I believe that was 4.2. We're going right down the list here. 5.1. And let's write this guy down. We got 5 times the absolute value of x minus 10 is greater than or equal to 40. Right. So if you've been working right down the list, you ought to be getting this stuff down pretty much. X minus 10 and greater than or equal to 40. Equal to 40. So the first thing we want to do is get this thing in a standard form, and that is where we just have the absolute values over here on the left hand side. Okay, the absolute value of something. And so we've got this 5 over here, so let's go ahead and get rid of this guy. And that means that we're going to be multiplying by the reciprocal to both sides, 1 over 5, right, to get rid of that 5 there. So we did that, and now we have x minus 10, and of course 1/5 of 40 is 8, right? So now we have it more in the standard form. And so now what we can do is go ahead and work this out like we've been doing. Right, so we have x minus 10 is greater than or equal to 8. And then of course remember this thing, think of it as an arrow pointing to the right. So we have or, and so now we have x minus 10 is less than or equal to, and we make that a negative 8. Alright, so we have x is greater than or equal to 8 plus 10. So x is greater than or equal to 18, and x is less than or equal to negative 8 plus 10, and so x is less than or equal to 2. 2 greater than 18 and less than 2. It's quite interesting. You're probably like, when am I ever going to use any of this? Well, for example, I use it for programming this website, believe it or not. Sometimes I need to find integers that are only in this particular interval, and let's just go ahead and write this out. So we got x is less than 2. We'll put 2 here, solid spot, dot, fill it in the blank, whatever. And then we have 18 over here. So there may be some reason that you need this particular interval. And this is one way to write it. You can write it in a while statement or an if statement. Okay. In other words, if, and then, some x is greater than that, well, then make something. If this is true, then blah, then, do something. And this is one way doing that. So yeah, this stuff you can use it, believe it or not. Okay, and what are we doing here? We're using brackets, union 18 to infinity, like that. Now let's pick a number. For example, let's pick 10 is a good number to pick in here. 10 is between 2 and 18, not in this interval. And if you were to pick 10 and plug it in right here, what do we get? We get 10 minus 10 is 0. And of course 5 times 0 is 0. And 0 is not greater than or equal to 40. So as you can see here, or let's say you wanted to pick 3. 3 minus 10 is negative 7. And the absolute value of negative 7 is positive 7. And 7 times 5 is 35. And 35 is not greater than or equal to 40. Alright, so you see how that works. If you were to plug 0 in, now 0 is in this interval here, an element of this set. If you were to plug 0 in, you get the absolute value of negative 10, but the absolute value of negative 10 is 10, and 10 times 5 is 50, and 50 is greater than or equal to 40. See that? Ooh, I'm out of wind on that one. Okay, so where are we at? Let's go back to the website, the web page, the web something or another. Okay, well, I'm not going to actually show you this, but there's obviously a mistake in the scripting, so I got to go in there and check that, but I'll have that worked out by the time you see this. Anyway, and that's the reason I do this, is go back and check my work. But anyway, you got the answer. You know the true, this is it right here. Okay? Negative infinity to 2, union 18 to infinity. Let's plug this in, for example. 2 minus 10 is 8. And of course, 8 times 5 is going to be 40, and 40 is greater than or equal to 40. Okay, so there you go. And we're up here at gotomath.com. Come check that out, and I'll see you later. Okay, we're here at gotomath.com. So that's where we're at. Click on Algebra. Let's go down to absolute value inequalities. And we are looking at, I believe, 5.2. 5.2. Okay. Alright, find the solution set and write in interval notation. We got 3 times the absolute value of x plus 4 is greater than 84. Alright. So, what are we doing? Bring up the magic board. 3 times the absolute value of x plus 4 is greater than 84. So the first thing we're going to do is get this in the more of the standard form where we have nothing but the absolute value over here on the left hand side. And that means that we're going to get rid of this 3. We're going to multiply both sides by 1 over 3, the reciprocal that number. So now we're left with the absolute value of x plus 4 is greater than 84 over 3. And 84 over 3, question is, does that reduce down? And actually it does. So we want to go ahead and rewrite this. I would have not have known that. 28 times 3 is 24. Yeah, okay. So now what we're going to do is go ahead and drop these absolute value bars and solve for x. So we have 28 minus 4, and therefore x is greater than 24. Now let's go ahead and rewrite this up here, or actually I guess we'll go straight across here. Never mind. Look at that. So this is x plus 4, flipping the inequality and making that negative. Alright, so we'll go ahead and subtract 4 from both sides, so we have x is less than negative 32. Right? Okay, so remember this is pointing to the right, and that means should trigger the word or. Okay, and let's go ahead and draw a number line. Try to draw a straight number line, it's kind of tough. So we got x is greater than 24. We'll just put 24 right here. How's that? And remember, it's an open circle because we don't include 24. So it's everything greater than 24. And let's go ahead now and we'll just plot negative 32 here. Right? Open circle and everything going off in that direction. And of course our interval is easy to write now because we can just look at our picture. And we got negative 32 parentheses because we don't include it. That's what the open circle means. Union, we're going to union that set with 24 to infinity. Okay, how's that? Pretty simple stuff. Negative 20, yeah, greater than 24. Okay, just making sure. We had an issue in the previous problem where in the scripting, I had a while statement in there, and it was actually after the problem script that's supposed to display here and cause some issues anyway, but we got that straightened out. So shouldn't have that problems in this one here. So there you go. That's the answer. You can type it in up here. Check that out. I think we should probably do that. So let's just do that. Negative infinity, negative 32. Make sure everything's going to work out there. Union 24, comma, infinity. Hold our breath, correct. Okay. So there you go. Alright, so you can come on by gotomath.com, practice, and I'll see you later. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And I believe we're doing 6.1. Right, so we'll want to write this one down. 7 times 8x minus 14 is greater than 10. Okay. Let's bring up the whiteboard. Alright, so we have the absolute value of 8x minus 14, and that's greater than 10. Okay, so the first thing we're going to want to do here is get this in more of a standard form where we have just the absolute value signs over here, and that means we're going to multiply both sides by 1 over 7 to get rid of this. Okay, so now we're left with the absolute value of 8x minus 14 is greater than 10 over 7. So now we can go ahead, drop the absolute value bars. Alright, and I guess while we're at it, we'll go ahead and do this side over here. Remember, it's pointing to the right, so remember, think of the word or. Okay, and we got some background noise, I think, here that was slightly unexpected. Don't know what's going on. I think something's being cleaned out. Okay, so let's take that 14 to the other side. So 10 over 7 plus 14, and then we're left with 8x. And go ahead and get that. So we have 10 over 7 plus 14. I'm probably going to go a little faster than usual here. I don't know. I wish I'd have known about that noise in the background before this all happened. And now we just take that 8, or multiply both sides by 1 over 8. And so we have x, and then of course this would be 8 times 7. Let's go ahead and do this. So we have 1 over 8 divided by 56, right? Times 7 is 56. 27 over 14. 27 over 14. So x is greater than 27 over 14. Now let's go ahead and do this side. 10 over 7 plus 14. We have 8x. And so we have negative 10 over 7 plus 14 on this side. We get 68 over 7. There's that 88 over 7. Just a second here. Okay, never mind. That's going to be 88 over 7. And of course we have x is less than, and this is going to end up being it's going to end up being, let's see, 88 over 56 Alright, 88 over 56, and that's going to reduce down to 11 over 7. 11 over 7. Okay. So let's go ahead and attempt to draw a number line there. Sorry about that. So we got x is less than 11 over 7. We'll make this 11 over 7 and open circle, everything going off in that direction, and then 27 over 14. Okay, open circle and going off in that direction, and that's going to be 1 point something or another, and that's going to be 1 point something or another, but that number's bigger. Okay, so anyway, so there you go. I guess what we need to do now is go ahead and write the interval. So we have negative infinity to 11 over 7 union 27 over 14 to positive infinity. Okay, and let's go ahead and bring up the whiteboard and see what we got. Alright. Okay, so you can come on by gotomath.com, practice that, and I'll see you later. We're at gotomath.com. Click on Algebra, and let's do absolute value inequalities. That's what we're working on. Click on 6.2, and let's get this one written down. We've got 18 plus 5 greater than or equal to 17. Okay, got it. We got it. I got something. I got, let's see, 18 times the absolute value of 10x plus 5 is greater than or equal to 17. Greater than or equal to 17. So the first thing we're going to do is let's get this 18 over here to this side, right? So we got 10x plus 5 is greater than or equal to 17 over 18, and that's not going to reduce down, right? Just take that diagonally down. Or you can think of it as multiplying both sides by the reciprocal, which is 1 over 18. Okay, now we go ahead, drop the absolute value bars. So you should really be catching on to this by now. All right. And we'll take that 5 to the other side. 17 over 18 minus 5. And that 17 there is kind of morphed into some other weird symbol. How's that? Okay. And so now we have 17 over 18 minus 5. And I think we can figure out what that is. That's just negative 73 over 18. Negative 73 over 18. Okay. And of course, now we've got x is greater than or equal to. So we'll go ahead and take that 10 diagonally down. So this now becomes 73 over 180. And the question is, does that reduce down? And I don't think so. So we have negative 73 over 180. Okay, I'm not sure you can see that on the screen, so we'll reduce that, bring that up a little. Okay, so now let's look at this part here. So we're going to go ahead, rewrite 10x plus 5, dropping the absolute value bars, flipping the inequality, and making this negative. Alright, so we'll go ahead and take that 5 to the other side. Becomes minus 5. And now we have 10x is less than or equal to. So 17 over 18, let's see, I'm getting negative 107 over 18. That's what I'm getting. 18 times 5 is 50, 40, 90, 17. Yeah, okay. Alright, and then we have x is less than or equal to. Take that 10, bring it down. So it's going to be looking like 107 divided by 180. And that doesn't reduce down any. So negative 107 over 180. Okay, so that looks like that's less than 1. Or anyway, that number there. Okay. Alright, so let's draw a picture now. Remember, the picture's worth 1,000 words. Okay, and of course we try to attempt to draw a straight line. X is greater than negative 73 over 180. We'll say 0 is right here. How's that? So this is negative 73 over 180. And this is going to be negative 107 over 180. X is less than or equal to, so we want to make sure we put a solid line dot here, and then everything in that direction. Then of course a solid dot here because we're including it now, and then everything in that direction. Of course the stuff in the middle, right, we can't use it. Okay, so we'll go ahead and write this interval out now. We got negative infinity to negative 107 over 180, and we use brackets, right, because we're including it, union, then a bracket, negative 73 over 180 to infinity. How's that? Okay, so anyway, negative 107 over 180 union negative 73 over 180. Yeah, looks good. Well, maybe I should scroll up so you can see it. Okay. Alright, of course you can always get some values and test that out. Make sure that's all good. Alright, so we're over here at gotomath.com working some algebra. Come on by, see you later. Okay, we're over here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And I believe we're going to be looking at something here. 7.1, I believe. 7.1. Whoa, we got a less than value here. So whatever this is, it's gonna, whatever x is, it'll have to be between 0 and that number. Right? Think about it. And it's pointing to the left. Okay. So that's going to be an and, isn't it? Not an or, but an and. So 15x minus 25 is less than 5. Okay. So finally, something a little different than what we've been doing. We have the absolute value of 15x minus 25 less than 5. Less than 5. Right, so we want to drop the absolute value bars. We've got 15x minus 25 is less than 5, and then remember this is going to be an and. Because it's pointing, think of this as the head of an arrow and it's pointing that way. Okay, so we have dropping the absolute value bars, we have 15x minus 25, flipping the inequality and making that negative. Okay, so let's look at this one here first. So we have 15x. Now take the 25 to the other side, so it becomes plus 25. Whoa, I left out the x there. So that becomes 15x is less than 30, right? And so we have x is less than 30 over 15. And of course we want to reduce that down. as much as possible, and that looks like x is going to be less than 2. X is less than 2. Okay, now let's take a look at this one here. So we have 15x is greater than negative 5 plus 25. Take that 25 to the right, makes it positive 25. Now let's simplify that down, and that just becomes 20. And so now we have x is greater than 20 over 15. X is greater than 20 over 15. And of course that will reduce down because 5 goes into both 20 over, or goes into both 20 and 15. And so we have x is greater than 4/3. X is greater than 4/3. So now let's go over here, draw a number line, and let's see what we got. Well, I'm going to plot 2 here on the number line, and let's actually use blue. And of course, look at here. We use an open circle, and we'll do this up here on the top. So that's everything to the left of 2, everything to the left of 2. Now what is 4/3? Well, 4/3 is less than 2, right? Obviously, it's 1.33. Let's go ahead and just put 0 here on the number line so we know where we're at. So let's see, this would be a 1 right here. So I don't know, 1 point, let's just say right here. Try to get it to scale as possible. And this is greater than, so we're going to put an open circle, and it's everything going off, we'll put it up here, everything going off in this direction. Okay. But here's the deal. The deal is when you pick a value, okay, now remember this is an and right here. When you pick a value, it has to satisfy both this and this. In other words, you pick a number, 1.75, let's say. We pick some number in here. It's got to be true for this guy. It's got to be greater or less than 2, and it must be greater than 4/3. See that? So, okay, we can't pick something like, for example, 0. 0 might be less than 2, but 0 is not greater than 4/3, right? And if we went up here actually and looked at that, for example, if you plug 0 in right here, what are you going to get? Well, you're going to get negative 25, but the absolute value of negative 25 is 25, but 25 is not less than 5, so you can see that right there. Okay, so we're using and means it must satisfy both this and this. Okay, so that means that we're going to be saying, now we're going to be using a parentheses because we got open circles here. All right, so we're going to be saying 4/3 and 2. In other words, that's going to be your solution set. Okay, numbers that are inside of this interval here, which represents this guy right here. Okay, see that? So it's important, right, to know the difference between and or. And or. So think of and, right, for this guy right here. This is the less than symbol. See that? And remember, or was for when the inequality pointed in this direction, and it could be that there, right, or this. But in this case, it's just the less than. Okay, so let's keep that in mind. Something a little different this time. We'll move now between 4/3 and hit it. 4/3 and 2. There you go. Okay. Not that bad. Alright. So what are we doing? We're over here at GoToMath.com practicing our absolute value inequalities. And I'll see you there. Okay, we're over here at GoToMath.com. Click on the algebra. Let's go down to absolute value inequalities. And I guess we're looking at 7.2. 7.2. So let's write this down. We've got the absolute value of 16x plus 10 is less than or equal to 46. Less than or equal to 46. All right. Okay. the absolute value of 16x plus 10 is less than or equal to 46. So the first thing we'll do is go ahead and drop the absolute value bars. Remember, this is an AND, okay, because it is pointing to the left. And when we think of AND, I didn't mention this in the last problem, you should think of intersection. Okay, think of intersection. It's where the two intervals intersect. Right? And let's go ahead and rewrite that over here now. We got 16x plus 10, but this time, remember, we flip the inequality, make that a negative 46. All right. Now, what do we got going on here? We're going to go ahead and work this one over here first, as usual. So taking that 10 over to the right, we got 16x is less than or equal to 36, and then of course taking the 16 diagonally down over 16. And I got to find out what that buzzing noise is. Okay. Somebody's on the website. I get these Google Analytics push notifications. Alright, never mind. Sorry about that. We got 36 over 16. Just never know. 9/4. So x is less than or equal to 9/4 after we reduce that down. Now let's work on this side over here. So we have 16x is greater than or equal to negative 46, and of course we are subtracting 10 to both sides. Is that what I did here? Yeah, making sure. Okay, and so we end up with 16x is greater than or equal to negative 56, and x is greater than, bringing the 16 diagonally down, and of course we'll want to reduce that down, and what does that reduce down to? Okay. Go to negative 7 halves, negative 7. So 4 goes 7 times 8. 8 goes on 2. So that's 7. Okay. Got it. And wow, what's going on there? We got x is less than or equal to 9/4, so we'll put 9/4 right here. 0 is somewhere about here, we'll just say, and then we'll just say negative 7 halves is here. Now remember, we're going to include, we'll look at this one here, we include 9/4, so we want to put a solid dot. We're going to write it up here, okay? And then everything to the left of that, we should probably still keep going. And then let's look at this one here. We'll put the solid dot up here. And x is, well, over here, x is greater than or equal to negative 7 halves. So everything going off in this direction. Okay. Now, as you can see, remember I mentioned the this operation here, set notation for intersection. An intersection meant and. And in other words, when we pick a number, it's got to satisfy both this and this inequality over here. Okay, and we write this intersection. Okay, and I'm going to go ahead and do this. Now, if we were to look at this guy right here, x is less than or equal to 9/4, and that means that it would be from negative infinity 9/4. You see this? That would be describing this interval here. Okay, and then using the intersection, see that, the intersection, then we would say, okay, by looking at which one are we looking at here? X is greater than or equal to negative 7 halves. negative 7 halves, I see something that I need to do refix. So this would be, and first off, I need to write this. This includes it. I'm sure somebody out there was going, well, wait a minute, that should be a bracket, right? So you got negative infinity to 9/4, right? And we got the bracket here, and intersection intersects with negative 7 halves to infinity. Well, their intersection, this can actually be rewritten, and we'd rewrite it shortest way possible, and that would be, we would be going from negative 7 halves to 9/4. Okay, that's actually what we want to write. This guy right in here, which just includes these values right here. You see that? So that would be the more proper way to write that, and not this way. Okay, this is a much better way of writing that. Okay, so negative 7 halves and 9/4. Yeah, and of course there you go. Okay, alright, we are working right on down the list, getting this knocked out. Anyway, we're here at GoToMath.com. You can come on by, practice that. See you later. Okay, we're here at GoToMath.com. Click on the algebra. Let's go down to absolute value inequalities, and we are looking at 8.1. Okay, find the solution set, write in interval notation. So let's go ahead and write this one down, and get that out of the way. 20x minus 28 is greater than negative 6. Alright. So we got the absolute value, 20x minus 28 is greater than negative 6. Alright. Now, remember that no matter what we plug in here, okay, the whole thing, the whole output is going to be either greater than or equal to 0. Right? We can fix a number that we can plug in here to get 0, or anything greater than 0. I mean, that's what the absolute value is all about. So, we got this thing greater than negative 6. So it's like no matter what we plug into here, it's going to always be greater than negative 6. So I want you to think about that. Okay? But we're going to go ahead and go through the algebraic steps of like we've been doing, and see what we arrive at. Okay? Okay, so we drop the absolute value bars and then go ahead and solve for x. Now remember, this is pointing to the right. Okay, it's pointing to the right, and that means or. Alright, so we've got to keep that in mind. And go ahead and rewrite over here, 20x minus 28. This time we're going to flip. Right, multiply that by a negative, so that becomes positive 6. So let's go ahead and solve for x over here. And so we have 20x is greater than, and what is that, 22? Right, 28 minus 6 is 22. Okay. And so now we have x is greater than 22 over 20, and of course that's going to reduce down to 11 tenths. So x is greater than 11 tenths. Alright. So these kind of problems are designed on a test to basically take your time up if you don't know what you're doing, because you should know exactly what the answer is without having to write all this stuff out. Okay? What that interval is. But this is just to make sure that you know, do you really know what you're doing, what's actually going on here. So they put stuff like this on a test, and this is to use your time up, so be careful out there. Right? So we got 20x is less than, them teachers can be tricky. Alright, and so we have 28 plus 6, which is 34, So we have 20x is less than 34, and so x is less than 34 over 20, and of course that's going to reduce down to 17 over 10, less than 17 over 10. Now I'm just going to get a little approximation going on here so we kind of know where these guys are at on the number line. And of course this is going to be slightly bigger than 1 there. Right, 1.1 kind of just helps us see where we're at on the number line a little better, I think. So we're going to scribble out our number line here, and let's go ahead, look at this one here. X is less than 1.7. First off, let's just go ahead and put 0 right here. Okay, so we're going to say this is 1.7, and or 17 over 10 I should say, and x is less than that. So let's put a open circle and everything going in that direction, right? Means that x is less than 1.7 I mean. And now this one here, x is greater than 1.1. I don't know, we'll put it right here, what the heck. And then so this is 1.1, here we'll put it down here. X is greater than, so that's going to be everything going off in that direction, everything going off in that direction. Now remember, this is pointing to the right, so think of that as an or statement. Okay, so that means that you can pick a number, choose a number, right, anywhere to the left or anywhere to the right. And what's kind of funny about the or statement is somewhere hidden in that or statement is an and statement, because this guy right here, if you picked a number in here, this would be in both, satisfy this and this right here, right? So that's kind of the funny thing about the or statement, is it can be this or that or both. Okay, or both. Okay, so we're going to go, so what we really want to do here is just say, look, right, from negative infinity to positive infinity. Because if you were to go ahead and write this out, this would be negative infinity 17 over 10 and union, and then of course 11 over 10 to infinity. But that's kind of silly, because what does this mean? It just means this, right? It just means that, since they're overlapping as they pass each other somewhere right in here. Okay, right, negative infinity to positive infinity, bam, you should be able to look at that problem and see it immediately. If you don't, you don't really understand what's going on here. Okay, alright, there you go. Okay, so we are somewhere. We're over here, gotomath.com. Come on, practice. See you later. Okay, we're over here somewhere. We're over here, gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And we are looking at some tricky ones here. Let's look at 8.2. 8.2. Okay. Let's take a look at this. We got the absolute value of 20x minus 29 is less than negative 17. Is less than negative 17. What happens when we actually work this out algebraically? It's kind of the question. 20x, and I guess we'll do that, is less than negative 17. Okay, so let's go ahead and go over here to the magic board. I don't know, I don't know why I'm calling it magic board. Alright, so we have the absolute value of 20x minus 29 is less than negative 17. Now we'll go ahead and drop the absolute value bars. And solve for x. So we got negative 17 plus 29. And what do we got there? 9 and 3 is 12. So we got 20x is less than 12. X is less than 12 over 20. And therefore x is less than, and of course that's going to end up reducing down to 3/5 it looks like. X is less than 3/5. Now let's go over here and do the other side. So we have 20x minus 29. Flip the inequality and multiply that by negative, so that becomes positive 17. Now remember this guy right here, it's pointing to the left, so think of the word and, which is also associated with intersection. Okay, so let's go ahead now, solve for x here, 17 plus 29, and whoops, left off the x, didn't I? So 17 plus 29 is going to be 46. So we end up with 20x is greater than 46. X is greater than 46 over 20. And of course that easily reduces down to 23 over 10. So we have x is greater than 23 over 10. Now let's get, well, I guess we don't need to do that. I was going to get the decimal representation of both those numbers. Okay, so remember and also remember intersection. Okay, that's important here. X is less than 3/5. Let's see, let's just put 0 here, and we'll put 3/5 here. X is less than 3/5, and so, right, that'd be everything going off in that direction. Okay, now 23 over 10 is going to be a little larger. We'll put that over here, right, and we'll put an open, so you know what, we'll just do it right here. How's that? I guess this is what we're going to do. We're going to, I'm just going to, let's just put it here. So x is greater than, so everything going off in that direction there. Now, I want you to look at something here. We're using the word and, okay? In other words, when we pick a number on the x-axis, it must satisfy both this inequality and this inequality here. And remember, it's intersection, okay? And remember what intersection means. You know, what do both of these sets have in common? Now we're going to go ahead and write this set here, and of course it's intersected with this set, 23 over 10 to infinity. Okay, now if you took this set and you intersected it with this set, what do both these sets have in common? In other words, is there an x value that is both in here and also in here? Is there a number on the x-axis that's both in here and in here? Well, not in the real space. Okay, I'll just tell you that. And so guess what? This is actually equal to the empty set, or we could actually say no solution. This doesn't have any solution. It doesn't have a solution. And this is another, so this is a way to prove this, I guess. We could, this is a proof, sort of a proof, proving this. It doesn't have a solution. And let's now go back up to here. Well, remember that this output right here is either going to be 0 or greater than 0, right? I mean, it's got to be a number including 0. Greater than or equal to 0, this output is. What does this say? This is a negative number right here. Negative. There are no x values that you can plug into here that's going to be less than negative 17. There's not one. Not one. You can't find one. Forget it. Right? It's going to be less than negative 17. So immediately, this is no solution. Right? This has no solution. or you could say empty set. Now there's really no way of writing this in interval notation that indicates an empty set that I know of, right? But there is a symbol out there. You can write this, or you can do squiggly brackets and write that right there. Okay, and didn't mean to click on that. So the solution set is empty. Now up here you could actually just type in that right there, and I don't know, yeah, I do have that program. So that circle with a line through it means empty set, and that's something that's talked about in the section on sets, the very first thing. Okay, so there you go, another one of these problems, right? They could take up your time. You should just look at that and go, man, there's no solution to that, or the empty set. Okay, the interval that contains no elements. Right, so we're over here at gotomath.com. Check it out. See you later. Okay, we're here at gotomath.com. Click on the algebra. Let's go down to absolute value inequalities. And we're down here at 9.1. Whoa, what is that? What is that? So we got the absolute value of 10x plus 11 plus the absolute value of 7x plus 17 is greater than or equal to 81. Okay, bringing up the whiteboard. So we have 10x plus 11, right, and close that in absolute value bars, plus, and then we have 7x plus 17, and that's greater than or equal to 81. So we're going to work this just like we've worked all the rest of them previously. We're going to drop the absolute value bars, collect up some like terms, of course. So we have 10x plus 11 plus 7x plus 17 is greater than or equal to 81. So we're going to collect up some like terms. So this is going to be 17x plus, and then we have 11 and 17 is 28, I believe. Okay. Right. Greater than or equal to 81. And now we can go ahead and take that 28 to the other side. 17x is greater than or equal to. So we have 81 minus 28 and 50, which is 53. We have x is greater than or equal to 53 over 17. Okay, and now what we'll do is, I think what I'm going to do here is, so this is going to be the same. Now remember, this is pointing to the right, so think of OR and union. Okay, so the only difference here is we're going to end up, so let me just go ahead and rewrite it right here. Alright, and that is, let's put a line divider here. So this is going to be 17x plus 28, right, after we drop the absolute value bars, collect up like terms, except this time we're going to flip this and make that negative, okay? So we end up with 17x is less than or equal to negative 81. Bringing the 28 over to the right, minus 28, and of course 81 minus, or negative 81 minus 28 is, okay, I think this is right, negative 109, 89, yeah. Okay, 17x, and then we have x is less than or equal to negative 109 over 17, and that doesn't reduce down any, so there you go. Okay, looks like we've got some stuff left over from the last problem. that needs to be erased, actually. Okay, no problem. No problem. No problem. Whoa, what happened there? So x is greater than 53 over 17. We'll say this is 53 over 17. And of course, it includes it. We'll put a solid dot and everything going off in that direction. And kind of arbitrarily over here, we'll pick that to be 109 over 17. Solid dot because it includes it, right? X is less than. So everything going off in that direction. Okay, so we'll go ahead and write our interval, negative 109 over 17, and of course we're going to use a bracket to include that, union 53 over 17, infinity to infinity. Okay, got that? We'll go over here. Right, negative 109 over 17 union. I guess I could scroll up so you can see that. But I want to make sure. Okay, that's all good right there. And you know what? It's been a while since we've actually typed anything in, and I think we're going to do that. We've got a second or two left. Negative 109 over 17, and of course we're going to use not those. Those are curly brackets. We want to use straight brackets. 53, I think they're just called brackets actually. And then infinity and parentheses. Okay, so let's make sure that's right. Hopefully it's programmed correctly. Yes. Okay, so there you go. So don't be too intimidated because we have a sum of two absolute values here. Right, just work it like you usually do. However, I have come into some different situations where if this was a minus, we had a minus in there, but we're not going to talk about that. Okay, that's just, there you go. Okay, what are we doing? Tell you what we're doing. We're going to exit this place. That is at gotomath.com. See you later. Okay, we're over here at somewhere, gotomath.com. Click on Algebra. Let's go down to absolute value inequalities. And what are we doing? I think we're down here, 9.2. 9.2. Okay. So let's scribble that down. 15x plus 19 plus 3x plus 9. And that's greater than 88. Greater than 88. Right? So we'll move over here to the whiteboard. We got the absolute value of 15x plus 19 plus, and then we've got the absolute value of 3x plus 9. 3x plus 9. And that's greater than, you can't drive any faster than 88. Or you got to go 88 to get into the future. Does anybody recognize that? 3x plus 9, 15x plus 19. Okay. I just wanted to make sure. So the first thing we're going to do is go ahead and drop those absolute value bars. Drop it like it's hot, would you please? 3x plus 9 is greater than 88. Okay, so we have 15x, 3x is 18x. We're just collecting up some like terms here. 19 and 9 is 28. And that's greater than 88. You have to drive 88. Anyway. Okay, what do we do now? Well, we're going to take that 28 over to the other side because it is bad boy. Minus 28. And now what do we got? We got 18x is greater than 88 minus 28. And I know we all know what that is. It seems like we spend most of our time just doing arithmetic. Is that my imagination or what? 60 over 18, and obviously that's going to reduce down to 10 thirds. Reduce down to 10 thirds, so x is greater than 10 thirds. Okay. Let's, we're gonna, whoa, that's supposed to have been a divider line. We're going to go ahead and start here because what are we going to do now? Well, we're going to flip the sign and make that negative. So we have 18x plus 28. That would remain the same on the left. Okay, so now we have 18x is less than negative 28 minus, wait a minute, what the heck? That's what I'm talking about, man. Negative, what are we doing here? Bring that over. Let's go ahead and just do like that. So now we have 18x is less than, and of course 28 and 88 is 116. So minus 116. So we have x is less than negative 116 over 18, and obviously that's going to reduce down to something. Let me think about this for a second. 58 over 9. X is less than negative 58 over 9. Negative 58 over 9. So remember, this guy's pointing to the right. That means or, and also think of union. You're going to union both of these sets, right? And so we've been doing number lines, so we might as well just continue to do that so you can kind of see the picture there. Alright, so let's say that this is 10 thirds, and we'll say this is negative 58 over 9. So x is greater than 10 thirds. Put a hole there. Everything greater, of course, you know, that's kind of exaggerated, isn't it? It's like I'm catching some other stuff, but you understand, right? You got it, and then of course everything to the left. Okay? And so we have negative infinity to negative 58 over 9 union 10 over 3 to infinity. 10 over 3. So what happened to 0? 0 got left out of this deal. 0's in here somewhere, right? So if we were to actually go up here, let's plug 0 in. So this just becomes 19. 0 in. This is 9. And 19 plus 9 is not greater than 88. So you can always take some values and check that out. Okay. What are we doing now? Oh, we're going to check, see if the script is all good. Negative 58 over 9. I always hold my breath on this part. You know, it's 10-3. It's like, oh my God. I did find a mistake in an earlier one because I had a while statement. Actually, after the problem was displayed, in other words, we came up with the variable numbers for the variables here and or here, and then we had this while statement, and if something particular was to happen, then we would want to change these numbers, and that's what happened. So I don't know if I ever explained that to you. It was back in 5.1, I think. Anyway, I got that all corrected. What's going on? Oh, I guess we're done. We're done with this anyway. Okay, so we're over here at GoToMath.com. You can come on over, practice. See you later. Okay, so what are we doing? We're over here at GoToMath.com. That's what we're doing. And click on Algebra. Let's go down to absolute value. Absolute value something. Absolute value inequalities. Forgot what I was doing. Started thinking about something else I don't need to be thinking about. That's for sure. Alright, so let's write this down. We got 15 over 7x minus 1 over 17 is greater than or equal to 19 over 15. So really basically what's going on with these last two problems, it's all about dealing with fractions. Alright, so maybe you don't have your fractions completely down. This might help out, who knows. Alright. So that's really the story. Kind of run out of ideas, so I'm like, well, let's just do some fractions. So we got the integral. Forget that. We got That's something in calculus, so don't worry about it. Negative ones. I don't know why I said that. The integral. It's not that tough, I promise. You can move on right on over there to calculus and find out what that is if you want. If you dare. Okay, so what do? Well, we drop the absolute value signs. Now we're dealing with some fractions. Yay! I know that's what you were saying to yourself. Yay! And of course, remember it's pointing to the right, so that means or. Think of union also. Then we got 15 over 7x. And I don't mean the union up at the university. No, actually, it is kind of the same, believe it or not. The union. I think most colleges have unions. It's where everybody meets up, right? They join up. You join both sets up and get a bigger set. Okay, what do we got going on here? Let's do this one here. So let's go ahead, take this minus this negative 1 over 17 to the right. So we have 15 over 7x is greater than or equal to 19 over 15 plus 1 over 17 plus 1 over 17. So we're going to need to get that into one nice fraction. And this section's not a section on how to calculate fractions, okay? So this is kind of, we're not going to get into that. If you want to learn how to do fractions, you need to move over to the fraction section. I'm getting 338 over 255. Isn't that a nice, lovely number? And now we've got, let me just go ahead and write this over here, 15/7 x. And so now what we're going to want to do is multiply it. Now I will tell you this. We're going to multiply this side by 17 over 15, and that means 7 over 15, not 17. And that means we got to do the same thing to this side over here, so those guys will cancel out. I will give you a hint on that. Aren't I nice? X is greater than or equal to, and oh Lord. So we're going to multiply that by 7 over 15, and hopefully something cancels out. And man, I got bad news to tell you. I didn't get much canceling out on that deal. So we got 23/66, boy, what an exercise, over 38/25. Isn't that lovely? Alright, so let's now look at this side. Ooh, I bet you guys were going, look, he's about to make a mistake. We want to, so we flip that, to do that, and make that negative. I don't know why I didn't do that. Alright, and let's just put kind of a line divider here. Okay, so take that over to the other side. So we have 15 over 7x is less than or equal to negative 19 over 15 plus 1 over 17. So I'm going to let you figure that out. I hope I didn't make any mistakes here. That is not going to be good. See, good news is I get the same denominator. Okay, so 15 over 7x is less than or equal to negative 308 over 255. So that's actually kind of good. And then, so once again, we'll multiply both sides by 7 over 15, less than or equal to negative. And so 308 times 7 is some big number divided by 255 times 15 divided by 255. Nasty. Alright, 21. Wait, my pen didn't want to write there for a second. It's like I'm not dealing with those kind of numbers. 3825. Isn't that terrible? Okay, so we have x is greater than and x is less than or equal to negative, whatever that is. Let's just go up here and 2156. Yeah. Okay. Let's look here. X is negative 2156 over 3825. Okay, and x is greater than 2366 over 28 or over 3825. 2366. Alright, okay. So, not nice numbers to be dealing with. No, it's not. Alright. Okay, so what are we doing? We're over here at gotomath.com doing some algebra, working some inequality, absolute value inequalities. That's what we're doing. Alright, see you later. Okay, we're over here, gotomath.com, click on the algebra, go down to absolute value inequalities, and I believe we're looking at the very last one. And what is that? Alright, let's write that down. So I just thought I'd throw this in here. 14. So we've got a bunch of fractions we're dealing with, but moreover, it's the form that this thing is written in that can really throw people off, because we've been looking at it one certain way, and now all of a sudden it's written like this, and this might confuse people if they're learning this for the first time. Alright, well, we're going to get all that straightened out here in just a jiffy. In one jiffy pop. Okay. Well, we've got, I'm just going to go ahead and rewrite the problem here. We've got 14 over 11 is less than or equal to the absolute value of 11 ninths x minus 4 29ths. Now, the way I read these inequalities here, I read them from left to right. You know, 14 is less than or equal to, less than being this is the smaller end, right? If you were to look at distance or something, you know, I see people getting this shit wrong all the time, sorry. If you think of the distance from here to here, okay, well, this is the less than, this is lesser than this distance here, right? If you were to think of this as distance, that's kind of the way I see it. Right, so if we were talking about, let's say, the distance, d, and then this distance, and as you notice, the distance is going to what? 0, right? The distance is going to 0. The distance between here and here goes to 0. So this is the less than and the greater than. You can think of it that way. And I read these from left to right, or, you know, I read it in this direction. In other words, whatever this is over here, 14 over 11 is less than this number here. And of course, if it was flipped around the other way, right, this is the greater than part. Okay, well, that's the way I see it anyway. You could, you know, say that the absolute value is greater than or equal to 14 over 11 if you wanted to. Right, you could say it either way. Okay, well, let's get this written back into the form that we normally write this in, and that is the absolute value of 11 ninths. So maybe you can recognize this, and this is what I highly suggest that you do, right, if you see something like that. Of course, right, this part here, which is, some say that's the alligator's mouth, is pointing in that direction, so we want to make sure it's pointing at the absolute value. Okay? The absolute value, the alligator. I don't know. Maybe we should put some teeth on this guy. Then an eye. Looking like a piranha. Maybe we should put a fin there. And let's put a tail. Okay, forget it. Alright. Let's, you know, I'm just glad this is the last problem. So we've got 11 ninths x minus, I'm going to drop those absolute value bars, is greater than or equal to 14 over 11. Okay. We kind of got off on a tangent there, didn't we? Now, if you're wondering what that is, that's something that you learn about in calculus. We got off on a tangent. You've probably heard that, and you may not even know where that even comes from. Well, it actually comes out of calculus, kind of. Actually, it does. I guess it could come out of geometry too. What are we doing? We got to get this together. What is that crazy mess? 14 over 11, got to get a common denominator, do some cross multiplication, pull our hair out, if you got any. Thank God I still got hair. 450 over 319. 450 over 319. 11 over 9x. Of course, now what we're going to do is multiply both sides by 9 over 11. That's the reciprocal. That guy right there, that gives us the identity. Oh, never mind if you don't know what that is. All right, 9 over 11. The identity. Whatever. Okay, so we got x is greater than or equal to. Now, can we reduce that down any? And the answer to that question is, hold on just a second. Let me think about it. Whoa, hold on. My brain is still calculating. 9/11. Those numbers come up. And forget it. 450. Oh my God. 3509. So we got some lovely numbers coming up there. All right. Now what we'll want to do is, it's like, what happened here? Well, fish swam into our problem, it looks like. So we got 11 over 9. 11 over 9. X is greater than or equal to 4. Whoa, 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 whoa. This is what happens when you try to skip steps. I need to go ahead and rewrite this. 11 over 9, x minus 4 over 29. Flip the sign. Yep, I just about got away from me there. 14 over 11. Okay, so we have 11 over 9x less than or equal to 4 over 29. Bring that to the other side. It makes it positive. Minus the 14 over 11. Right. And of course we'll want to just do that in our head because we can do that, right? 14 over 11. And that's okay, we'll write it down here. 11 over 9x is less than or equal to negative, is that right? Yeah, 362 over 319. Okay, now what's the probability this thing's going to reduce down? That's the next question. What is the probability that it will reduce down? So now we'll go ahead and multiply both sides by the reciprocal. 11 ninths. So you have 9 over 11. 9 over 11. So 362 times 9 divided by 319 times 11. And looks like the probability is 0. Well, anyway. Let's see. Negative 3258, I believe, over 3509. X is less than or equal to negative 3258. You know, that's just too much for me. Too much for me to handle. 3258 over 3509. My God. 4050 3509. X is greater than or equal to. Okay, and less than or equal to. That is a headache. Headache wanted to happen. Alright, well, that's the end of this section for now. We'll be moving into the next section hopefully today. Not sure when, but anyway, it doesn't matter. Alright, so we're over here at gotomath.com. You can come on by. I promise if you've worked through all these problems in this section, you've at least got a good idea on how to solve absolute value inequalities. Okay? And see you there.